Heat can be transferred from one object to another in the form of waves, which travel straight through the space between. This is radiation. The radiation waves from this closed stove are invisible and are called infrared waves. The fire itself, being much hotter, gives light waves as well as more infrared. All very hot objects give a lot of infrared and some light waves. The boy absorbs radiation waves and so gets warm. All objects do this. People, furniture, walls. They do not get hotter and hotter because, at the same time, they lose heat. Walls, furniture, people, all radiate, but they are not hot enough to give light. The sun gives off radiation, and some of it falls on the glasshouse. Both light and infrared radiation reach the glass, but glass acts rather like this sieve. The sieve stops the larger stones, but lets the small ones and the soil go through. The glass stops the longer infrared radiation, but lets shorter infrared and light go through. The radiation is absorbed by the pots and warms them. So they radiate more, but give only long infrared which cannot pass through the glass. Thus radiation gets in, but not out. The temperature rises, the plants grow faster, and we have the benefit. Whitewash is used to prevent the glass house from getting too hot. Can you answer this question about it? Whenever it is cloudy in the daytime, it becomes cooler, because the clouds absorb some of the sun's radiation. This warms them, and they radiate more. But much goes out into space, and the Earth receives less. You remember that all objects radiate. Throughout the night, the Earth gives off infrared radiation. Can you answer this question? The Earth is warmed by the sun's radiation, though not evenly. Here are two equal beams. That near the equator is spread over a small area compared with that near the North Pole. In this experiment, the two circles of light are equal, but when the top of the paper is bent back, the upper beam covers a larger area, and each square inch receives less radiation than in the lower area. Now, near the pole, the Earth's surface is curved back, the radiation is at a slant, each acre receives only a little, and there is always ice and snow. Near the equator, the radiation comes down squarely. Each acre receives a lot, and conditions are tropical. Of course, this is how the people on the spot see the landscape. Remember, radiation striking the Earth squarely gives a lot of heat per acre, Radiation at a slant gives less heat per acre. Now, here is a little problem. Watch the angle of the radiation. The boy moves into the shade. But now he moves back again. The question is,